Okay, here's our wrap up on variation of parameters. So at the start, I said that we would work through a second order derivation. We would recap with the steps to solve second order, do a couple examples, and then expand to third order. And so we started off by explaining the problem we're solving. We're thinking about particular solutions, just like we did last class, but now we're thinking about only second order equations, and the trade off being that we get to have non constant coefficients. And we worked on this very long derivation that followed that same rule we've used in other sections of the class, where we say y is equal to u1 y1 plus u2 y2, or whatever we think y might be, and then we plug it in and try to learn what happens. And so this happened to involve a lot of calculus, a lot of clever simplifications. And I told you to kind of like take it easy in this section because really what's important is the process, understanding that this is a way that we solve differential equations. But in the end, we kind of arrived at a system of equations that characterize U1 and U2 for us. And then we talked about how it's actually easier to represent solving those equations as determinants. And we walk away with simple equations or formulas we can use for U1 prime, U2 prime. So we sum that up by saying that the approach for finding this type of particular solution is to assume that form, just calculate u1 prime, u2 prime using the right-hand side of our ODE, and then the solutions y1, y2 from the homogeneous case. And then we integrate that formula to get u1 and u2. We can go ahead and use that superposition principle to write our general solution like we did last section as well. So we did an example where I was a bit more careful in showing all the details, where we kind of plugged everything into our u1, u2 prime formulas, and then we had to integrate a couple functions of x, but they weren't too bad. And then we even did this thing where we pretended we got extra constants, and at the end we made sure to note that it's important to get rid of those extra constants because we'll only be able to solve for two unknown constants in a second order initial value problem. Then we looked at a spring problem, which hopefully is real solid with you all after working on your project, but we got to have this non-homogeneous part to it, represent driving a spring. And we made sure to note that this method only works if there's nothing on the leading coefficient for our highest order derivative. And in this example, I skimmed the details on our integration and algebraic simplification because it was quite a mess, and even pointed out that it probably wouldn't be so messy to just use undetermined coefficients in this case. Then we just had a quick note about the fact that we focus on second order because the formula is very unwieldy for higher order, but it is possible, and you follow this general approach to come up with the formula for higher order. And then I went ahead and wrote out the formula for third order just so that you would have it. And hopefully you can see the pattern now for if you needed to write it for even higher order than this. The determinants you can calculate using an online tool if you're not familiar with determinants, or even if you are, I mean, the online tool is probably easier. So I summed up what I thought we did right here on this conclusion page. So we were trying to solve y double prime plus py prime plus qy equal to f. And in this section, we just assume this problem has already been solved. We're finding our general solution for the homogeneous case. We take this form for what the particular solution should be, and we use our formulas to solve for the functions u1 and u2 in that solution. And then there's kind of this special warning that we have to make sure we only have two constants at the end. And then in general, you should think about what method's actually going to work best for you. So in my experience, students tend to really like variation of parameters because it has a formula, but I just want you to know that sometimes it's not the easiest thing to do, and you create kind of a big mess for yourself by not recognizing that another method might be easier. So your practice problem today is just to solve this differential equation, y double prime minus 2y prime plus y equal to e to the x, using variation of parameters. And so go ahead and work on that, give it your best effort, and I will see you in class.